Okay, let's crack on. So, hello, our attendees. Welcome to the last session of MQ stream in this year's GSC. I can see a couple of participants now here that attended the previous session, so you know how it all goes. But just I just wanted to say welcome and thank Matt for presenting. Discussed briefly with Matt on the presentation type, and I have allowed everyone to unmute themselves. So Matt agreed to take questions on the go if you want to unmute yourself and ask questions, or just pop the questions into the chat. Matt information is in agenda if you have any questions you want to ask directly, but obviously I will let Matt now introduce himself and start off with the presentation. So take it away, Matt.
Over to me. Okay, thank you. Right, so good afternoon or good morning, depending on wherever you are. My name's Matt Lemming. I'm an IBM architect for MQ for ZOS. I've been at IBM almost 23 years now, so I've been around for quite a long time. And my focus has been, in fact, most of my focus throughout my career has been messaging. And for the last 10 or something years, I've been working on MQ for ZOS. This session, right, so obviously I come from an MQ environment, and I'm going to be talking about MQ and Kafka. My intention is to try and be even-handed and not be too biased. But the idea here is I want to talk about MQ and Kafka, when should you use one and when should you use the other. And actually, a common theme will be the fact that it's often better to use both. And it really depends on what you're trying to achieve. Right? There's not just a right answer as you really dig into the questions. I'll be talking about that as I go along. If anyone has any questions as I talk, then feel free to ask. Because I'm not necessarily looking at the chat because I only got one screen in front of me. And,
Matt.
Yes.
So sorry, just a quick question and a quick note from the chat that you're a little bit echoey, and yeah.
Yeah, I don't know if I've got any solutions. I can promise you I'm saying things only once. So yeah, I don't think I've got an answer to echoes, but I will try and get a bit closer and see if that helps. So anyway, so I'll start going. If anyone has questions as you go, please ask. And then, as you said, more than happy to have questions, afterwards via email or whatever. And this is definitely a common conversation for us. Kafka is a very hot topic. It often comes up in the context of MQ as to, should we use one or the other? And that's really the reason for this presentation, because literally we talk about MQ and or Kafka all the time. This is not the first time today I've had a conversation about it already. The conversation about it yesterday, and we basically talk about this multiple times a week, and we have been doing for the last few years. Okay, so everyone is trying to figure out where Kafka's been around for quite a while actually. Lots of people obviously have MQ. Customers with MQ look at Kafka and try to establish whether they should use Kafka or not and replace MQ. And that's kind of the purpose of this presentation, because there is actually, if you go and look out there on the internet and try and understand when you should use when you should use Kafka and when is the right scenario for that as opposed to other messaging systems, there's quite a lot of, I guess, misinformation is one way of putting it, and that kind of generates quite a lot of fear and doubt and all the rest of it. And I'll give you an example on the next slide of where that sort of stuff comes from. But just to reiterate, this isn't which is best. Both MQ and Kafka are great tools when used in the right place. And actually, it's really the thing is, what problem are you trying to solve and what application scenarios are you working in? And then it's a question of whether you should use MQ or Kafka, or possibly MQ and Kafka together. And increasingly what we see is customers making use of them together, and they might have started off with MQ, move into Kafka, but sometimes we see it kind of going the other way as well. And that's kind of more towards the end of the presentation. So like I said, I do kind of talk about this sort of stuff quite a lot, and that means you end up doing quite a lot of research. And it's quite interesting if you go and look on the internet and say, well, yeah, what is the difference between MQ and Kafka? Then it'll summarize it. You know, you can get an AI summary out to the internet saying what the general feeling is on the internet. And so this is what Google showed when I did this probably a couple of months ago now. And it's in some places it's actually quite a fair comparison. So we talk about MQ and Kafka, and that they're both messaging systems and they're used for different purposes and they deal with things differently, which is totally true. They mention that MQ is traditional and it's good for security and reliability, which is totally true. There's weird stuff about JMS API and producer-consumer problem, which is just strange. When it comes to Kafka, here we're focused on the fact that Kafka is great for high-volume real-time data, but it doesn't really do a comparison like this. Kafka is great for this, but it doesn't really address the bottom-up MQ part of it. And it also talks about scalability without really comparing that to MQ. So it's not the most even-handed comparison, we think, when you kind of look at this in detail. And I will look at this in detail later. And then it kind of goes into some more specific details on the right. So when it comes to message delivery, so MQ is obviously all about exactly once and very prescriptive message delivery. And that's kind of where we excel. Kafka, here it kind of says, well, Kafka doesn't guarantee exactly once delivery by default, but that's something you can actually switch on. But actually, this is kind of one of those things where it's a fair statement, but it doesn't mention the fact that Kafka can do close to exactly once delivery. But to do that, you actually have to switch a load of the benefits of Kafka off. And so, there's definitely some detail that's missing here in this high-level summary. And configuration to do so isn't just to switch it on. You actually have to switch lots of other stuff off in order to get that. MQ is less suitable for real-time data processing, while Kafka is designed for it. I think that's something that's an interesting thing to pick at later, because people have been using MQ for real-time data processing for the last 30 years. Fair comments about Kafka using data, providing data durability and resiliency by replicating data. But actually, MQ does this. We've got lots of capabilities, regardless of your platform, for data replication, whether that's queue sharing groups on ZOS or things like native HA or replicated data queue managers and distributed. And then just a final comment about scalability, again, without comparing with MQ. So I think, if you look at this, it's actually quite biased. And this is kind of where the fear and uncertainty and doubt tends to come from. You look at this and you think, well, Kafka's got everything going for it, MQ hasn't. The last bit of here about the choices between MQ and Kafka, which one you should choose, I think we'd agree with this. Like, if you're going to choose, the best choice depends on what you're trying to do. It's not like a one size fits all sort of job. So the reason I shared this is really just to make you aware that if you just go and look at the internet and get an AI summary, which of course is really taking effectively a summary of the whole of the internet, you do get quite a biased choice, which answer, which I don't think is particularly accurate, because you read it and you think, well, MQ is traditional, so does that imply MQ is old and Kafka is new? Kafka is high throughput, scalable, and resilient, so that kind of implies MQ is not any of those things, which isn't true at all. And Kafka is for real time, so MQ is for some other thing. And what I'm going to do with the first half of this presentation, or maybe the first third, is to kind of pick at those things a little bit. So just starting off with the traditional versus Kafka being more modern, this is quite interesting, because actually Kafka's been around quite a long time now. So the first time people started saying Kafka started saying existing message brokers like MQ were traditional was in 2011, so that's 14 years ago. Okay, so if you just do it based on age, then 14 years ago, MQ was actually, well, MQ now is about 30 years old. So 14 years ago, MQ was 16 years old, which is exactly the same age Kafka was, or not exactly, is exactly the same age Kafka is now. So if you say traditional based just on age, I think you can say MQ and Kafka are kind of as traditional as each other now. They've both been around for a long time. They're both widely adopted. Yes, MQ's been around longer, but definitely Kafka's very widely adopted, just like MQ. So 15 versus 30 years is perhaps there's not that much in it. It's certainly not the case that Kafka is brand spanking new. It's definitely got a lot of history and heritage behind it. The other reason you typically see for Kafka being described as not traditional and new is because it's based on a distributed append-only log, and that's that's the functionality that underpins how Kafka works. But actually, those of you who've been using MQ for anything, you'll understand that actually underpinning any queue manager, whether that's on ZOS on the appliance or in distributed, we actually have an append-only log, which is how we provide message persistence and the ability to recover from failure. So MQ is underpinned by an append-only log. We use it differently, but still under the covers we make use of that. And MQ clustering allows the ability to have distributed partitions of queues effectively, and that's been around since 1999, so the last 25 years. So at a high level, and even if you kind of go deeper into it, the core technology underpinning Kafka isn't actually that dissimilar to the core technology underpinning MQ. It's how that core technology is exposed to the application. So MQ applications, they don't know that there's a distributed append-only log. They just interact with the queue and send and receive messages. Whereas with Kafka, that append-only log is much more apparent because the applications work through the events or the records stored in that append-only log and kind of move through it, and that's much closer to the application level because you have your offset into the append-only log that Kafka manages. So really, a key difference between these things is not whether one's traditional and one's new. It's actually what are the operation and application abstractions that underpin these technologies and how they're exposed to applications, and then what is the best way to exploit those abstractions based on the use case you're trying to solve. Because in some cases, often you can kind of maybe make either work for a given use case, but experience has shown that some use cases are easier with MQ and some use cases are easier with Kafka. And so you kind of need to really look at that rather than worrying about, well, MQ's been around for 30 years, so I shouldn't use that. I should use Kafka because that's 15 years newer. That's still been around for 15 years. So it really kind of comes down to what you're trying to do rather than age of anything or something like that. So if we kind of look at a high level purpose, MQ is all about communications, allowing your applications to communicate, transmit data between them back and forth, regardless of where they are, which platforms they're running on, and also the availability of the underlying infrastructure. So we very reliably in MQ will hop data between environments to ensure that temporary outages of bits of your network or your applications don't affect the flow of data around your MQ network. Kafka is around for something quite different. And it's not communication, it's really about taking data at large volumes and processing that stream of data as it's being produced to do something with it. And normally that processing of that data is used for generating insights into what's going on in your environment. That's kind of the original reason Kafka was generated, or was created. It was to collect large amounts of data being generated in real time and process it in real time, because when you've got large amounts of data, it's very hard to do that retrospectively because it's just basically impossible to keep up. So you're better off staying working with the data as it moves and keeping on top of it. And that's kind of the use case that Kafka was originally produced for. And so kind of Moving down the level, Kafka is all about gaining insights to your data as it's continuously changing based on your system's state evolving over time as it processes whatever work it's processing. Whereas MQ is all about decoupling your applications, from on-prem, on ZOS maybe, to applications running on the cloud and allowing them to communicate, or applications connecting between the clouds and dealing with the inevitable fact that there's often going to be latency between clouds or things like that. And so these two different purposes and business motivations actually are quite keenly felt when you look at some of the principal design decisions that underpin MQ and Kafka. So MQ, everything is all about individual messages are important. We try very, very hard to not lose messages. They're persisted. We have transactions to make sure that if something goes wrong, we don't accidentally send a message when it's not ready. And when we do move that message, the message goes by itself. It doesn't get patched up in the same way that Kafka does. Whereas Kafka is all about moving large amounts of data, and so it has optimizations to say, rather than sending individual events one at a time, instead build up a set of events before they're flushed out into the system. And another part of that is also, because you've got this large stream of events coming in, there's a big focus on in-order processing, and that's an absolute fundamental part of Kafka, whereas MQ is much more flexible for that. Yes, you can process messages one at a time for a single application, just getting those messages off, but also we allow scale out so that you have multiple applications processing a backlog of work and collaborating. You also see this kind of down into the trade-offs between the amount of logic in the client side of MQ and the amount of logic in the queue managers. So with MQ, a lot of the smarts is built into the queue manager. We worry about maintaining log state, all of the transactional tracking and things like that. Much less is done in the consumer layer. In contrast, and it's not quite done for a good smart consumer here, it's a lot more of the smarts done in the consumer layer to ensure that Kafka provides an efficient stream processing mechanism, and therefore less work is done on the broker layer to provide it. Obviously, there's still a whole load of processing that goes there, but it's kind of, there's definitely a balance shift in this environment. And again, back on this precision thing, so MQ is much more focused. When you send a message, you know whether that message has been sent or not, and you can control transactionally when that message arrives on the queue, whether you commit or roll back. Whereas with Kafka, by default, everything is batched and timer optimized. So you send a set of messages, and they don't necessarily go until a timer pops, and you actually say this set of data is good, push it in. And then the last point is actually MQ is not just about it's typically not just about a single queue manager. It's about a network of queue managers that route your messages to where they need to go. So some customers do just exchange messages via a single queue manager. A lot of customers actually route messages geographically around the world across 1, 2, or potentially more than that queue managers to get them where they need to go. And so you tend to have this system-to-system message transfer across a set of queue managers, whereas Kafka is much more, you send your data into a set of Kafka brokers, and that is where you take that set of state from to do your stream processing. It is less about routing data around a network, although it does provide the ability to do things like replication of data if necessary, but it's not such a key thing. And it's definitely not got the hopping around capability that MQ has. So this is kind of like a high-level summary. There's more detail on it on various bits of documentation, but there is quite a difference here in terms of how these things were designed, and that's kind of what you start to see. So if we kind of focus on use cases here, so we've kind of got 3 different aspects: communication versus data processing, sequence versus message-centric, and precision versus streamlined. I'm going to kind of draw up where MQ's best fit is versus where Kafka is. And there's always a bit of variation in exactly where you'd put these points, but this is trying to be relatively fair. So definitely MQ is we're focused on high precision, every message counts. Communication between applications is a very big thing, and obviously we're message centric. Whereas Kafka is much more, it's the sequence of data, the sequence of events that are important. Individual events themselves are not so significant, although they can still be useful. And it's definitely not communication, it's much data processing based. But if we take that use case focus, which I think is much more useful, and we compare that to what I was getting from the internet focus, actually see the differences, you'll see that actually there's not that much. There is a few bits here, but actually if you look at things like security, MQ and Kafka, they're pretty close. I think we'd argue that MQ has more security built in, although Kafka has closed that gap in recent years. I think metrics, MQ and Kafka kind of got the same level of metrics. Basically, if we kind of go around this list of comparisons that the internet was focusing on, in reality, while there are slight differences, it's much of a muchness. So actually, we don't really want to be thinking about that right-hand side. We want to be thinking about the left-hand side and focusing on your use cases. Your use case is. So I wanted to now kind of come to some of the other points I was pushing at earlier. The fact that Kafka is high volume, which is certainly true. And if you kind of take an arbitrary list of performance and kind of compare MQ and Kafka in two different modes, you kind of get this picture, right? So if you're trying to do event streaming, this is an area where Kafka excels, right? It's designed from the ground up to very quickly move data into applications to process in real time. So if you want real pure performance and you're doing event streaming, Kafka is absolutely the way to go. And you can kind of do event streaming to a degree with MQ. It's harder. The APIs aren't really designed for it. And as a result of that, you'll see the performance being less good from a streaming scenario perspective. However, if you want to do guaranteed message delivery and reliable communication of data between applications, what we see is that actually, and these are obviously very relative pictures. I haven't got any specific numbers to show here because it's actually very hard to compare this. MQ is actually faster, right? We're designed for guaranteed message delivery. Guaranteed message delivery does come with a certain amount of cost to make sure that you kind of provide that guarantee. But actually, we're pretty optimized at it. And experience has shown that Kafka, while it can do kind of guaranteed message scenarios, you have to switch so many of the optimizations off that make Kafka great for streaming scenarios. It really slows it quite down. And obviously, if you're kind of really just worrying about pure speed here, then it does start. You could say, well, actually, the whole point of messaging is to add value above and beyond just pure speed. So if you really were interested in just the highest performance possible, you go, well, I'd use TCP/IP and not worry about all of the network and sockets APIs that are different between different platforms myself. Or if you wanted to go really, really fast, you'll do UDP and worry about retransmission yourself as well. So this pure performance scale is probably not, it's not great to just look at this in a one-dimensional manner. It's also useful to kind of add reliability to the picture. And this is where things like TCP/IP and UDP completely fall off the picture, and you can get a slightly different view. So I think it's still fair to say that if you're in the streaming world, then Kafka is still the thing to go for, right? If you have a choice, Kafka is still the thing to go for here, because it's designed to be high performance for it. And actually, the way Kafka does streaming with its topic replication and things like that is more resilient than what we can do with MQ, because MQ wasn't designed for that. It's not designed for streaming. Yes, you can do it to a degree, but it's not designed for it. However, if you wanted to do guaranteed message delivery, then MQ is both more reliable because of the way we do our message positions and the way we have transactions and all of that functionality than Kafka is, and it's both and faster as well. So there's definitely a, if you want to do the guaranteed message communication style thing, then MQ is really the right answer, we think, on every front compared to Kafka. But if it's streaming, then really you should be using Kafka for that, because that's what it's designed from the ground up for, both the infrastructure that land all of the APIs that are available with Kafka as well. I also wanted to touch a little bit on real time, because it's kind of an interesting area, isn't it? Real time. What does real time mean? Because exactly what this has kind of evolved a bit over time. And there's this nice chart which is from a Perishable Insights article by Mike Gaultier, which kind of talks about how systems have evolved over time. It used to be that if you were doing decision making based on what was going on with your systems, you couldn't do that in real time because the act of processing it was too expensive, and you always got behind. And actually taking that data out of the system to do real-time processing, that it slowed down your main systems in the first place. But the best you could do was to capture some of that data somewhere and then process it in batch style transactions later, because otherwise it was damaging to what you were trying to achieve. And actually, we see customers still doing batch style processing with MQ. But actually, really, regardless of whether you're using MQ or Kafka, both of these systems are really, really quite fast. Okay, they can move data very quickly, and you get into an environment where we're not talking about processing data in seconds, right? We're talking about processing data in microseconds. It's just an example. If you're using MQ for COS and pushing it fast, our performance measurements say you can do 1.4 million messages a second, and that kind of gets you down to request reply processes happening at the time scale of milliseconds. So that is definitely real time, and Kafka is kind of in that same sort of general ballpark area as well. I think if we're being a little bit picky, which I'm going to be, we'd probably say because MQ is very message centric, we're even more real time than Kafka, because Kafka inevitably does this batching of transmission of events just to be more efficient. But that's probably nitpicking a little bit. Both MQ and Kafka are definitely real time environments where you're moving your data and reacting to that data at sub-second latencies. So with all of those comparisons, how do we actually make a reasonable choice? Just keeping an eye on my time here, so I don't run out. And I think really a good way, as well as just kind of bearing in mind what you said, is to look at what your applications are trying to do. And some of this I've kind of covered to a certain degree in some ways, which is the first way of splitting application patterns up is either batch processing or near real-time processing. Batch processing is probably not such a great use case, but the messaging infrastructure, that's really about, messaging infrastructure is all about exchanging data relatively close to real time period. So that's where we're going to focus. And actually, if you look at real time, you can kind of do a second split there between synchronous interactions and asynchronous actions. And so here, when I think of synchronous actions, we're talking about things like communication via REST APIs, where you need both ends of the interaction to be up at the same time for you to actually be able to do your work. So these are tightly coupled. You can't call the REST API, that REST API is not there. Whereas asynchronous environments, messaging environments are loosely coupled, because the idea of the messaging infrastructure is it decouples the applications that are trying to communicate. And so you send some data in to the messaging infrastructure, and that data is consumed at some later point by applications. And that later point might be, like I said, with microseconds approaching, microsecond, millisecond latency, or it might be a few seconds later, but you kind of do get this decoupling, which allows you to scale and have flexibility when there's inevitable bottlenecks or delays, which are temporary. So we're going to focus further on the asynchronous environment, because this is where messaging fits. And then we'll split these again. So when we talk about messaging, really there's kind of two bits of messaging. There's messaging as in you want to exchange data between two parties, and that exchange is kind of done on a per message basis. And messaging gives you a loose coupling there, in that they don't need to both be available at the same time. But really, the the thing that's being exchanged is the important thing, it's the message, and you do those one at a time, probably with a certain amount of back and forth. And then events is the other part of the puzzle here, where actually this is normally just someone sending data out there, and it's quite decoupled because the thing actually generating these events doesn't necessarily know whether anyone's listening to those events, right? You could send an event out saying, I don't know, I've updated, someone's just bought the last Twix from my shop. That's an event, and some people might be interested in that. One person might be interested in it, no thing, sorry, I shouldn't say person, thing should be interested in it. So that's kind of an event. You know, there's something has happened, that event's been put out there, and interested parties can do something about it. And whether, you know, and it shouldn't really matter how many of those interested parties there are, really, in terms of from the perspective of the thing that actually emits the event in the first place. And then actually you can kind of look at events in two different subclasses as well. One is where individual events are important, or sorry, not individual events matter, and you kind of want to go and look at one event and then another one will come along, and you don't kind of take those in context. You say, well, you know, this event happened, so I'll do something about this, and now this event happened, so I'll do something about that. So individual events become something you process, whereas event streaming kind of doesn't care so much about the individual events. It's how do these events show my system and my environment evolving over time. And you know, a single individual event, it doesn't matter really whether I process that or not. What is more important is getting that set of events moving through the system and working on it as it evolves over time. That's what event streaming is. So it's not the individual data point, the individual message, or the individual event that's important. It's the evolution over those events over minutes, hours, or whatever time frame is relevant, and what you can then do with seeing that set of events evolving and doing something smart with it. So once we've got this set of application patterns, there's a question really then of how does MQ and Kafka overlap? So we'll start off with MQ. You can see it kind of covers a few bases, but really our key area for MQ was always messaging, exact, precise sharing of data between applications back and forth on a per message level. And that's something we've been doing for 30 years. MQ has also for a very long time supported PubSub, which is also another good word or synonym for event notification. Okay, so that's something that's been around for, you know, in the product for decades now. And this is also an area we're great for as well. We do see some customers using MQ in almost a synchronous pattern where it's basically I'll send a message and I'll wait for a reply straight away. That's perhaps less of a good fit. You could also do similar things with REST APIs as well. But we actually do see quite a lot of customers doing that. That's fine. It's just not such of a perfect fit. And we do also see some customers do something that's sort of like event streaming, in that you deal with the stream of events coming in via MQ, but actually, well, you can do that. That's definitely the case, but really you should be using Kafka, because MQ's application APIs aren't really designed for streaming events. They're designed for get a message, do something with it, get a message, do something with it, which isn't such a great fit for event streaming. If we then try and take Kafka, you'll see inevitably the overlap is a bit different. I've just got a load of things popping up, so I'm just going to get rid of those. So Apache Kafka is suited, as I mentioned, from the ground up for event streaming. The whole purpose of it, when it was originally built, is take lots of data in, efficiently share that stream of data with applications in near real time, so they can do something smart with it. So that's definitely the whole point of Kafka. But of course, it's also a good use case or a good product for using event notification with it as well. And then we do sometimes see a bit of overlap into the what we would say MQ's more effective space of traditional messaging as well. It's worth pointing out in the event notification of the PubSub space, it does depend a little bit more deeper on what your use case is. So, like if if you look at what MQ does with regards to PubSub, we're better suited for environments where you might have lots of topics which dynamically evolve over time. Because from an MQ perspective, a topic isn't a big complicated thing. It's basically a way of matching producers of events to consumers of events. So actually, they're really quite lightweight. Whereas Kafka, topics are big things. There's a whole chunk of processing and disk space and all that sort of stuff that goes with an individual topic. So while you can have lots of topics with Kafka, you know, you can get into the thousands. With MQ, you can get into the millions with no real impact. And there's definitely this question of fine-grained. Kafka topics are not really fine-grained. You tend to have a smaller number for a specific purpose, where MQ topics can be very fine-grained, they can be dynamic, and they can evolve over time, and that's effectively much, really quite cheap. Whereas Kafka is much better at having lots of consumers for a smaller number of topics, because it basically doesn't duplicate the message data in the way that MQ does. With Kafka, there's effectively one copy of each event, and that one copy gets sent out to all of the available consumers, whereas MQ will generate one copy of the event per consumer and then send those events to the consumer. So that means while you get individual control when you consume those events, it does kind of push more work onto the queue manager. So it's worth bearing in mind there's definitely a difference there. And then the last point here is that traditionally we saw lots of customers, do batch processing later at the end of the day, and they might see the data in MQ for that sort of purpose or in the database. But actually, with things like Kafka, the act of producing that data and then processing it is so fast now that, one, the cost of producing the data in real time from the systems doesn't really slow the system down in the way that it would have done historically. And also, Kafka moves the data so fast, and the processing paradigms provided by Kafka's stream processing APIs is actually really fast, so you can kind of keep on top. So it does start to eat away into this older batch style processing, and we're seeing that more and more. So I'm just trying to make sure I stay online. So 7 minutes. So what did we learn? So I think the key thing is it's all about the use case. It's not about whether one is faster, because the question is, in what scenarios is it faster or more scalable or more reliable? You definitely want to think about the abstraction, because some abstractions, or MQ's abstraction, will work better for some environments, whereas Kafka's will work better for others. And actually, you probably want to be using these two technologies together. MQ and Kafka are definitely something we spend a lot of time showing customers how they work together. And I think, like if you go and look out on the internet, you'll see many big customers globally doing things with MQ and Kafka. And of course, this is something IBM wants to help you with, because obviously we have IBM MQ, but we also have our own actually Kafka product as well, which is IBM Event Streams. So when it comes to actually using these two things together, this is quite a common paradigm. Basically, Kafka has lots of connectors that allow data to be pushed into Kafka to do real-time insights. And so what we tend to see is that there's existing customers running on ZFS, running on distributed, that are already using MQ to exchange data between those applications. And that data that's moving between those applications is actually useful in terms of generating insight about what your business is doing. So having a copy of that data is valuable, and then you can take that copy of the data, push it into Kafka, and then do real-time analytics on it. And you kind of get this sort of picture here, where you have your order management system, which would be based on MQ, and you have a real-time insights engine that would be likely based on Kafka. And the question is, how do we get a copy of the data moving through MQ into Kafka? Animation now, and the answer to that is connectors. So Kafka has this rich ecosystem of connectors, which basically provide a way of pumping data from external systems into Kafka, or taking copies of data from Kafka and pumping them into external systems. And so what we see quite often is customers already have the data moving through MQ, and it's easy to use things like MQ streaming queues or MQ PubSub, to take a copy of the data that's already moving through the MQ system and then put it on a separate queue, which you then take the data from that queue and push it into Kafka. And to do that, as I mentioned, there's these Kafka connector things, which are basically a standard set of approaches for pushing data into Kafka. And so you can get this piece of technology called a Kafka Connect worker, which sits there and is basically a pump, taking data in, pushing it into brokers, into your Kafka brokers. And IBM provides, if you've got an advanced entitlement, or if you've got IBM Event Streams entitlements, support for an IBM provided source connector, which can reliably transmit data from an MQ queue and push it into Kafka, and also we go the other way as well. But it's this connector up top, the source connector that takes data from MQ into Kafka. That is the one that is generating lots of conversation at the moment. And literally, it's every week we're talking about it to one or more customers. So I think the key thing here is if you're looking at doing this sort of thing and you've got a need to get data into Kafka and you already have MQ, then these connectors are a great way of doing that. And they high throughput, reliable, and also provided by IBM and supported by us. So the next part of this is, as I mentioned, so we have our own Kafka product, which is IBM Event Streams, which is based on the open source Kafka distribution. And also we have a number of other capabilities called IBM Event Stream, IBM Event Endpoint Management and IBM Event Processing, and together they make up a kind of an Uber product called IBM Event Automation. So in the last 3 minutes, I'll quickly stream through those. So IBM Event Streams is basically Apache Kafka designed from the ground up to run in a containerized OpenShift-based environment. It gives you lots of nice UI support for interacting with and monitoring and understanding your environment and seeing what's going on. And it also provides the connector functionality I was talking about on the previous slide. So this is the core event processing logic provided by IBM, which is a great use case for using with MQ. Now, what we tend to see is that once customers start to make use of Kafka and generate a lot of topics, they typically start to find it hard to understand what they've got and who else can make use of that data. It's great once you've got an existing use case for Kafka and an existing set of data going into that, it's actually quite valuable to be able to reuse that data for other purposes. And the challenge tends to be, how do you know what you've got? And it's kind of the same sort of thing you get with REST APIs. There's been a challenge with REST APIs in the past. It's just like, I've got lots of REST APIs. How do I know what I've got? How do I know I'm not recreating the wheel? This is where event endpoint management comes in, that you can publish the available Kafka topics and share them out. And then the last bit is, once you've got all these Kafka topics, you don't necessarily have to codify the processing on them and write your own apps to do that. IBM Event Processing provides like a simple drag and drop UI to do that processing for you without low code editor to actually go and do this functionality. And that's based on the Apache Flink topic. So sorry I rushed a little bit towards the end, but hopefully what I've managed to do there is explain that Kafka is great, but so is MQ. There's a good use case for both of these, but it does depend on what you're trying to do. Often you will find that there's actually value in using them both together. And if you do use them both together, then you should be making use of the connectors to wire data, push data from MQ into Kafka or data from Kafka into MQ. IBM provides its own set of supported connectors with either MQ Advanced or Apache Kafka. And then the last bit I talked through was a quick summary, which was unfortunately a bit rushed, talking about what IBM offers in the event processing area, which is our own event streams, distribution, as well as capabilities for event discovery and also simple low-code event processing. So hopefully that was useful. If anyone does have any questions, I don't see any other new ones in the chat, you can reach out to me. And thank you for listening.
Thank you very much, Matt. Great presentation. Just a closing remark from me, maybe. I believe that I used to work in MQ space, and I think Kafka just opened the my eyes a little bit, because it felt like MQ always was more of like transaction handling, as in passing transactions, and more transactional. Kafka actually allows, it's just data passing technology, both of them, isn't it? So data not necessarily needs to be customer data or any sort of that. In Barclays, we currently use Kafka event hubs for login and monitoring a little bit, just to passing the data that needs to be consumed somewhere further. So Kafka does enable different view of MQ. It's not necessarily for application and transactions and customers and all that. It can be for other purposes as well, and Kafka is very well utilized for that. So yeah, so I think it's a great presentation and great comparison in between those two and how they can work together. So thank you very much for that. We do value feedback, so as I always say, please provide that. I have allowed people to unmute themselves if they have any urgent questions now, but cautious of time. I might just let you guys to all enjoy your evening now. And if any questions on Kafka and MQ, Matt is your guy. His information is in our agenda on the session, and please email him and with any questions whatsoever. And so yeah, if no urgent questions, one more second waiting for anyone to unmute.
Doesn't look like it.
Okay, let's wrap up. Thank you very much again, Matt. It was great. Thank you everyone who attended today's stream. It was good to learn about what's new in MQ, all about the Kafka and MQ, and all about the Zero Trust and everything that the presenters presented. Thanks again, and have a great evening, and enjoy the rest of the conference. Thank you, Matt. Cheers all. Bye. Thank you.